While all engines feature different designs, features, materials, webbing, reinforcement, there's some things that all engines share. Now, one of the things that all engines share is a deck, and all engines are either an open deck, a semi-open deck, or a closed deck. Today we're going to dive in, find out which one is better and why. With all modern engines, the block and the cylinder head are created separately from each other and then later bolted together to create the engine. Now, the deck is the surface at the very top of your block, which is the surface that the cylinder head mates to. Now, the job of the block is to provide rigidity for the cylinders, obviously give a surface for the cylinder head to mate to, and also allow coolant to surround the cylinders and then pass into the cylinder head where it can cool the head. There are three fundamentally different types of decks, which is open, semi-open, and closed. And the names refer to basically how the deck looks and how it allows coolant to pass through it. An open deck, as the name suggests, is pretty much fully open between the cylinders and the engine block walls. Open deck designs have a coolant channel cast into the top of the deck. This design improves cooling and reduces hot spots in the cylinder, but provides much less strength and rigidity at the top of the cylinder. A closed deck is basically the opposite of an open deck, and it's nearly fully closed. And I say nearly fully closed because the deck surface is only drilled for the head fasteners, coolant passages, oil supply, and oil drainback passages. The tops of the cylinders are integrated with the deck, and this configuration is found in pretty much all cast iron blocks and some high-performance aluminum blocks. Semi-open falls somewhere between an open deck and a closed deck design, and every semi-open deck is different. For the most part, it's going to look like an open deck, but with some bridging between the cylinders and the block walls. The area where it bridges is going to be different for every engine. Looking at it from a top-down perspective, it's pretty easy to see which design is which. And for reference, we can look at a Subaru EJ engine, and you can see that the open deck design pretty much has a big open area between the cylinders and the block walls. And the semi-open looks a lot like the open, but it has a little bit of bridging between the cylinders and the block walls. And then closed is pretty much closed off except for a few passages for coolant and oil, and those passages need to line up with the passages on the head and the head gasket. For the most part, you're going to hear people say that a closed deck is stronger than an open deck block. And while this is fundamentally true because more material and more reinforcement around the cylinder is going to make it stronger, that doesn't mean an open deck block is bad. And to demonstrate this, we can look at modern high-performance engines, and a lot of them are open deck. For reference, the Honda K20A and K20C are both open deck, although one of those is naturally aspirated. The BMW N54 and N55 are both open deck. Ford's 2.3 liter EcoBoost is open deck. But on the other side of the spectrum, the BMW S55 and the new B58 are both closed deck. Nissan VR38 is closed deck, and so on. As you can see, with modern performance engines, it's kind of a mixed bag of closed deck and open deck designs, and that's just a testament to the point that open deck is not necessarily a bad thing. If you look at some older engines, you'll find that a lot of older engines are closed deck. For example, 2JZ's closed deck, Nissan RB26 is closed deck. The SR20 is a closed deck. Mitsubishi's 4G63T is a closed deck. The general trend here is that modern engines are kind of a mixed bag of closed and open deck designs, whereas older performance engines are pretty much just closed deck. But the question is, why would a manufacturer use an open deck design, especially for a modern turbocharged engine, if closed deck is significantly stronger? And the reason mostly comes down to manufacturing costs and thermal efficiency. One of the big downsides to a closed deck design is that it's more expensive to manufacture compared to an open deck design. When you're manufacturing tens of thousands or potentially hundreds of thousands of engines, the cheaper manufacturing method can result in literally millions of dollars saved for the manufacturer. So it makes sense why they would want to use the cheaper method. Not only is an open deck design cheaper to manufacture, with modern materials, casting, and machining, open decks are a lot stronger than they used to be. A long time ago, it was common to hear somebody cracking or blowing out the cylinder walls on an open deck block, but that's really not the case anymore. You really don't see these issues occur very often. Another reason a manufacturer will use an open deck design is for thermal efficiency. Heat management is key to producing an efficient engine, and in today's world, engine efficiency is pretty much the #1 thing that manufacturers are going after. So it makes sense why a lot of them are using an open deck design, because it's just a more efficient design. The area where you're typically going to see strength benefits from using a closed or semi-open design is at the very top of the cylinder. Since there's really not all that much air pressure when the piston is all the way down at the bottom of its stroke, there's really still not that much pressure when it's midway through its stroke. But at say the last inch of its stroke, there's a massive amount of air pressure, and that's where you're going to see the strength benefits from a closed or open deck, because that extra reinforcing is just right there at the top of the cylinder where the peak pressure is. In an open deck design, this is where you could possibly see failure, since there's not a whole lot of rigidity holding the cylinder in place inside the block. There's all that space in between the cylinder and the block wall, and when you're having that much pressure in that small of a space, that's where you can see cracking or the cylinder wall blowing out entirely. If not cracking, you could possibly run into cylinder distortion, which causes a whole host of other problems and will eventually result in catastrophic failure. So yes, a closed block is stronger than an open deck block. There's more material and there's more structural integrity. But with modern designs, materials, and manufacturing methods, the strength difference between the two isn't as drastic as it once was. Many modern engines use a closed deck design, and many of them also use an open deck design. Open deck is cheaper to manufacture, and for most applications it's strong enough. If you're building some sort of crazy high horsepower application where cylinder pressures are going to be way past they were ever designed for, then a closed deck will theoretically be the better option. Somewhere in between a closed deck and an open deck is a semi-open deck, which provides a little bit of the best of both. It's important to note that if you're comparing two different engines, the design of the deck isn't really a big factor. Yes, it's important, but there's a lot of other things in an engine that can fail, and looking at just the deck is skipping over everything else in the engine block that can potentially fail when you're massively increasing power. So a closed deck block is not always going to be better than an open deck block. The deck itself might be stronger, but there's still a ton of other things that you need to look at. That brings us to our next point, which is, can you take an open deck block and convert it to a closed deck block? Say you were building a huge, maybe 1,000 or 1,200 horsepower application. Could you take an open deck block and make it a closed deck to support that application? And the answer is yes. Converting an open deck to a closed deck block typically involves installation of a billet aluminum plate, which sits in between the cylinder walls and the block walls. The plate will feature holes that allow coolant to pass through it, just as it would with a closed deck. The insert is typically pressed in so it doesn't jiggle around, since that would effectively eliminate the benefits of reinforcing those areas. Once it's pressed in, it's typically machined so it's completely flat, and the only way you can really tell that there's been an insert there is that the color of the billet aluminum might be different than the color of the cast aluminum that the block is constructed out of. Now, if you're going for something absolutely insane, like a 2,000 or 3,000 horsepower application, some manufacturers offer full billet aluminum blocks which feature a closed deck design from the start instead of an open deck design. To answer the question of which one is better, yes, a closed deck design is better. It's stronger, it has more material, it has more structural integrity, it's going to support the cylinders more. But that doesn't mean that it's always going to be better than an open deck block, since there's a ton of other things in the block that could potentially fail. So if you're building some sort of crazy high horsepower application, yes, a closed deck might be marginally better than an open deck design. But if you're not building something absolutely insane, say something less than 700 horsepower, an open deck is probably going to be fine for most situations. For reference, we could look at the Honda K20C, which is an open deck engine. It's the new engine found in the Civic Type R, and a lot of tuners have pushed this way past its stock power limits, and they're pushing it upwards of 400, 500, even 600 horsepower, and the block is just fine. This again just shows that you really don't need a closed deck design unless you're pushing some crazy power number. So that's pretty much everything I've got for you guys today. That's pretty much everything you need to know about closed deck blocks and open deck blocks and which one is better and why. If you guys enjoyed the video, please hit the thumbs up button because it really helps out the channel and it helps YouTube put this video in front of more people. If there's anything you think I forgot or anything you want to add or correct, please let me know down in the comments below. And also let me know what videos you want to see in the future. Smash that subscribe button because it really helps out, and I'll see you guys in the next one.